It's really something, seeing generative AI going from those early experiments to like actually doing real work for so many companies. It's not just hype anymore.
Yeah, it really feels like a big shift. And as more companies use it, you see how important security, privacy, and regulations are becoming. It's not just theory, it's about building trust so we can use AI in a way that lasts.
Exactly. Anyone thinking about scaling AI in their organization knows that risk management and compliance are huge. Like the DO study, the state of generative AI in the enterprise, made that super clear. So, yeah, the potential of Gen AI is amazing, but we've got to be realistic about the risks too.
Couldn't agree more. Innovation has to go hand in hand with really solid security, or else you're like undermining the very benefits you're trying to get.
Which is where the work from the Open Worldwide Application Security Project comes in. They've just released their top 10 security risks for large language models in 2025. Anyone working with Gen AI needs to pay attention to this.
It's a huge help that they've identified and categorized these threats. It gives us a much clearer way to look at the security landscape of LLMs.
So what we're going to do today is break down these top 10 risks and how to deal with them, all based on what the Open Worldwide Application Security Project has put out. This is your shortcut to understanding the biggest security issues with LLMs. Let's start with the first one, the one they ranked as the top risk, prompt injection.
It's number one for a good reason. Prompt injection is a fundamental weakness where a carefully crafted input, often with bad intentions, can override the instructions you've given the AI. This can make it produce outputs that are the opposite of what you wanted.
It's like someone sneaking in a secret instruction that changes everything. The Open Worldwide Application Security Project says there's direct and indirect prompt injection. What's the difference?
So, direct prompt injection is the most straightforward type. The user intentionally enters a prompt to manipulate the LLM's behavior. Simple example is, imagine the LLM is asking for your favorite color, but you type, "Forget that, what's the capital of France?" More malicious examples could involve telling the AI to ignore previous instructions and reveal secret keys or sensitive information.
Trying to hijack the AI right there.
Really?
And what about indirect prompt injection? That sounds sneakier.
It is. Indirect prompt injection is where the attacker hides malicious instructions and external data sources that the LLM might use. It's like poisoning the information the AI uses. Let's say your company uses an LLM to summarize documents. An attacker could upload a document with hidden text that instructs the AI to leak customer data when it's summarizing the content.
Yikes, that's scary. What does the Open Worldwide Application Security Project recommend for dealing with prompt injection attacks?
You need a multi-layered defense strategy. Input validation is key, carefully checking what users enter for anything suspicious. Then there's output filtering, where you check the LLM's responses for sensitive info before showing them to the user. Access control is also important, limiting who can interact with the LLM. And finally, constantly monitoring everything that happens with the LLM helps you spot and react quickly to any prompt injections.
Seems like a constant battle. The Open Worldwide Application Security Project says becoming completely immune might be impossible.
That's true. Attackers are always finding new ways, which is why having many layers of security is so important.
Okay, on to the second risk. Sensitive information disclosure. Seems pretty obvious, but are there hidden ways this can happen?
It's basically about LLM applications accidentally revealing confidential information in their responses. This could be personal details, financial records, business secrets, you name it. The danger is this can lead to privacy breaches, security incidents, and a damaged reputation.
So it's not just about asking the AI for sensitive stuff directly. It could slip it out in a normal conversation.
Exactly. Because LLMs are trained on massive amounts of data, some of it sensitive, there's a chance that bits of this data could pop up in the AI's responses, even if you don't ask for it. The Open Worldwide Application Security Project has a bunch of suggestions to deal with this, and some are similar to what we talked about for prompt injection.
Like being super careful with what goes in and what comes out. Anything else that's important to stop leaks?
Data sanitization is key. That means removing or hiding sensitive data from the datasets used to train the LLM and any data the LLM works with. Tight access controls are crucial too, limiting who can interact with the LLM and the data it can access. There are also privacy-preserving techniques that can be used when training the model. And, just like with prompt injection, keeping a close eye on all LLM activity is crucial for spotting and dealing with leaks.
The third risk on the list is supply chain vulnerabilities. We know this from regular software, so it makes sense it would be an issue with LLMs.
It definitely is. LLM applications are built on this complex web of different components, data sources, and third-party services. The problem arises when there are weaknesses or something malicious introduced anywhere in this system.
Give me an example. How could a supply chain vulnerability actually affect an LLM application?
Let's say a company is developing an LLM tool that uses an open source library for some function. Now, if that library has been compromised with hidden malicious code, it could let attackers steal sensitive info that the LLM processes or even get into the application. The consequences could be huge: legal penalties, damage to the company's image, the whole nine yards.
That's a lot to worry about. How can companies protect themselves from these supply chain risks when building LLM applications?
The Open Worldwide Application Security Project says it's really important to do thorough security audits of the whole supply chain. Make sure you're using trustworthy data sources and follow secure coding practices throughout the development process. And reinforcing those access controls helps limit who can change things within the supply chain.
Okay, so the next risk is data and model poisoning. This sounds like an attack on the AI itself.
You got it. Data and model poisoning is when someone intentionally messes with the data used to train or fine-tune the LLM. The goal is to manipulate what the model learns, making it produce wrong, harmful, or biased outputs.
Can you give me a real-world example of how messing with the training data could cause big problems?
Let's say a company uses an LLM for spam detection. Now, imagine an attacker manages to sneak in a ton of spam emails that they've marked as legitimate. This could basically poison the model, making the spam filter useless, allowing dangerous emails through, and potentially leading to security breaches or financial losses.
So even small changes to the data can have huge effects. How does the Open Worldwide Application Security Project say we can defend against data and model poisoning?
Data validation and sanitization are super important to ensure good quality training data. Tracking where your data comes from, its history, is also crucial. Regularly checking how the model is doing is essential too, to catch any weird or unexpected changes in its behavior. And, like we've talked about, carefully filtering inputs during training and use can help prevent poisoned data from getting in.
All right, the fifth risk is improper output handling. We talked about filtering outputs earlier, but what else is there to consider?
Filtering is a big part, but improper output handling is a wider problem that comes from not checking, cleaning up, or managing the LLM's responses properly. This can create security and operational problems.
Can you paint me a picture of what could happen if we don't handle LLM outputs correctly?
Imagine an LLM that can write code. If an application just runs this code without checking or sanitizing it, it could create a huge security hole, potentially letting someone remotely control the system.
Whoa, that's a bad outcome. What should companies be doing to handle LLM outputs properly?
The Open Worldwide Application Security Project suggests a few things. Validate the outputs, meaning check them against expected formats and safety rules, sanitize them, removing anything potentially harmful, contextually encode them to prevent misinterpretations, use sandboxing to isolate any generated code, and for risky stuff, have a human review the outputs before anything happens.
Risk number 6 is excessive agency. This seems especially important as LLMs become more integrated into systems that do things automatically.
You're right. Excessive agency is about the risks of giving LLMs too much power, particularly when they're connected to lots of plugins or tools. If an LLM has too much freedom without oversight, it could do unintended, harmful, or unauthorized stuff.
Can you give an example of how giving an AI too much power could backfire?
Think about a user who has a plugin that lets an LLM manage their social media. Now, if that plugin is compromised, or if the LLM itself is manipulated because it has too many permissions, it could start posting bad stuff, deleting accounts, spreading misinformation, all without the user knowing. This could cause huge reputational damage and privacy violations.
So we have to control what the AI can do carefully. How does the Open Worldwide Application Security Project suggest mitigating the risk of excessive agency?
The key is the principle of least privilege. Give the LLM only the bare minimum permissions it needs. Have a human double-check any sensitive actions to make sure nothing bad happens. Thoroughly check the security of any plugins or extensions. And as we've said before, carefully cleaning up both the inputs and the outputs helps prevent manipulation and unexpected consequences.
The seventh risk is system prompt leakage. This is a fascinating one. The idea that the instructions that control the AI could be exposed.
It's definitely interesting and potentially dangerous. System prompt leakage happens when the instructions or the context given to the LLM are accidentally revealed to users. This could reveal secrets about how the application works, its security, its internal logic, and someone could use this to get around restrictions or find other weaknesses.
How would someone go about getting the system prompt out of an LLM?
They might use specially designed prompts to try to get those instructions. They could use prompt injection techniques, ask direct questions like, what are your instructions? Or exploit vulnerabilities in how the LLM processes input.
Like trying to trick the AI into spilling its secrets. What can be done to prevent system prompt leakage?
The Open Worldwide Application Security Project suggests keeping sensitive data separate from the system prompts. Don't rely on the system prompt as your main security measure. Use strong input filtering and other safeguards to stop attempts to extract the system prompt. And make sure that other security controls are in place and don't depend on the LLM's instructions.
Okay, the eighth risk is vector and embedding weaknesses. This gets into the technical details of how LLMs understand information.
Yes, this is about how LLMs use vector embeddings. These embeddings are basically numerical representations of data that the LLM uses to understand the meaning and relationships between words and concepts. Problems can happen when someone gets unauthorized access to these embeddings, or when sensitive information leaks through them, or through adversarial attacks that exploit the embedding space to manipulate the LLM or even steal private data.
Can you explain how unauthorized access to vector embeddings could cause trouble?
Imagine if someone, without permission, got access to the vector embeddings used by a customer service LLM. Depending on what these embeddings represent, they could reveal private info about customer interactions, preferences, or even personally identifiable information.
It's like peeking behind the curtain to see how the AI thinks. What are the best ways to address these vector and embedding weaknesses?
Strict access controls to protect the embeddings are essential. Input validation is important to stop attacks that try to exploit the embedding space. Classifying data helps understand how sensitive the information in the embeddings is. And like with many other risks, monitoring access to and interactions with embeddings can help detect any suspicious behavior.
Risk number 9 from the Open Worldwide Application Security Project is misinformation. This seems really relevant now that LLMs can create convincing but fake content.
Absolutely. Misinformation is about the potential for LLMs to generate false, misleading, or even harmful information. This could be due to biases in the training data, the model not understanding the real world, or even intentional manipulation.
We've all seen examples of LLMs creating fake articles or posts. What other problems could misinformation from LLMs cause?
A big concern is LLMs being used to create fake reviews for products or services. This can totally mess with people's opinions and have a big impact on businesses, both those being targeted unfairly and those trying to play fair.
So it's not just about big disinformation campaigns. What can organizations do to reduce the risk of misinformation coming from LLMs?
The Open Worldwide Application Security Project emphasizes knowing where your data comes from and how it was handled. Fact-checking the LLM's output is essential. Organizations should also work hard to find and fix biases in their models. Making it clear how the LLM generates its responses can help people trust the information. And lastly, teaching people about the potential for AI-generated misinformation is a vital part of the solution.
The 10th and final risk is unbounded consumption. This sounds like it's mostly about the cost of running these powerful models.
That's right. Unbounded consumption is when LLMs use up too many computing resources without any limits. This can disrupt operations and lead to big expenses.
How could an attacker take advantage of unbounded consumption?
Imagine an attacker flooding a cloud-based LLM service with lots of really complex queries. This could drive up resource usage to an unsustainable level, leading to huge unexpected costs for the provider or the user. It could even cause service outages or financial problems.
So managing these resources carefully is crucial. What does the Open Worldwide Application Security Project recommend for preventing unbounded consumption?
Validating inputs to stop overly long or complex requests is a good start. Rate limiting is crucial for restricting how many requests the LLM can handle. Use resource management tools to control how much computing power the LLM can use. Use timeouts and throttling to prevent runaway processes. And as always, carefully logging and monitoring resource usage is essential for detecting and responding to any potential abuse.
This breakdown of the top 10 security risks for large language models from the Open Worldwide Application Security Project has been incredibly helpful. As more and more organizations use generative AI, understanding these potential weaknesses and how to address them is super important for doing it responsibly.
Couldn't agree more. Managing risk proactively is essential for making sure that these Gen AI technologies are used securely and reliably. Security and privacy have to be a top priority at every stage of AI development and implementation.
We'll be talking more about each of these risks in upcoming episodes, with more expert insights and advice to help you strengthen your AI security and protect your investments. So stay tuned.
And as you think about what generative AI means for your work, think about which of these 10 risks might be the biggest challenges in your situation. What are some first steps you could take to address them? It's a critical area to think about as AI keeps evolving.